Hello students, in today's session we are going to discuss dependent samples E-test and dependent sample W-test that we also call the pair T-test and pair W-test. Pair T approach or pair W approach we apply when we identify the samples given in the question as dependent samples. And dependent samples we can identify as when two different sorts of treatment or types of treatments are given to the same subjects and we take before program or prior to the program or prior to the treatment readings from the same subject, and from the same subject we take after program or after trial or after treatment readings. And the question is 10.75. An exercise physiologist wants to determine whether a certain type of running program will reduce heart rate. He measures the heart rates of 15 randomly selected people who are then placed on the running program. 1 year later, the exercise physiologist again measures the heart rates of the 15 people. The heart rates both before and after the running program are displayed in the following table. Do the data provide sufficient evidence to conclude that the running program will on the average reduce heart rates? So what we do, we need to first state the null and alternative hypothesis, as the question is focusing on the perspective that whether the running program reduces heart rates. So we state our H0 and H1 as the mean heart rate before program equals after program. The mean greater than sign, therefore there is no need to divide alpha by 2, and we take 0.05 level of significance. Test statistic for the paired t-test is T d bar. D bar represents the mean value of paired differences. So we need to consider the two observations, one before another after, taken out from the same individual or subject. We need to consider it as the pair. Mu d bar divided by SD divided by root n is the formula. Now we define critical region. We assign or allocate the probability of 0.05 to the right tail critical region, and then we consider the t-table. And since we are given 15 observations in the data, that gives us 14 degrees of freedom. So we go for this value of 1.761 at the intersection of t.05 and 14 df. So 1.761 is the right tail critical value, and we state the decision criterion as H naught would be rejected if T calculated exceeds 1.761. Now, after the step of defining critical region, we go for the step of computation. And step of computation, we take paired differences, considering each pair. So 68 take away 67 gives us plus 1. Then second observation is 76 take away 77 minus 1. 74 gives us 0 and minus 3. So minus 1, 0, minus 1, 0 and 1 minus 3. Then the fifth pair gives us 71 take away 69, 2, then again 2, then again 4. So 2, 2 and then 4. 2, 2 and then 4. Then we have 83 take away 77 gives us 6. So 6 and then 4 and then 0. 6, then 4, then 0. Then this is 3, then this is 9, 3, 9, 7, 3. So 3, 9, 7 and 3. And then the last one is minus 2. Now what we do, we work out the mean of all these differences and then work out the standard deviation. And this is how we can get the t statistic or t calculated. The mean value that we have computed for the pair differences is 2.33 and the standard deviation is 3.35. So we can now compute the t value as 2.33. Take away mu d var value is 0, 3.35 and then divided by square root of 15. This is how we can get the answer computed. Now work out the value. That's 2.33 divided by 3.35 and divided by square root of 15. That's 2.693 is the t calculated value. And now we write down decision and then conclusion. Decision we write down as, since t calculated falls in the rejection region, therefore H naught is rejected and it can be and then conclusion we can write down as, the test results are statistically significant at the 0.05 significance level and data provide sufficient evidence to conclude that the exercise reduces heart rates. Now we can apply W test on the same question or example as paired W test, in which the null and alternative hypothesis remains same, but only the assumption changes to the paired differences are approximately symmetrical or have the identical shapes. or pair differences are symmetrically distributed. We take it as an assumption. And if we are going to apply on this question the pair t-test, we need to consider the assumption that must be given as the pair differences are approximately normally distributed. So now what we can do, we can mention here W is equal to sum of positive ranks, and we take the right tail critical value from the W table, but before that we need to consider a condition for the application of W statistics, that the pairs that are giving us zero difference need not to consider in our analysis. So the total number of observations that are valid observations given in the data are reduced to 13. So what we do, we first go for the W table, and from W table the level of significance is 0.05, whereas the number of observations are 13, so it gives us a critical value of 70. So you now take critical value for W statistic as 70. On the same sheet, what I'm doing, I'm drawing the W curve, and you need to state the rejection condition accordingly. That's H naught would be rejected if W calculated is exceeding 70 and not otherwise. Now what we'll do, we'll start taking absolute values at the first place: 1, 1, 3, 2, 2, 4, 6, 4, 3, 9, 7, 3, 2. Now we start giving ranks to the numbers or to the values, absolute values of D. So there are two ones. So their average rank is 1.5 assigned to both. Then we need to consider 2 is occurring 3 times. If these numbers were different, then they must have been assigned the ranks of 3, 4, and 5. So we go for the average of 3, 4, 5. That's 4, 4, and 4. Then ranks till fifth number has been assigned already. The next higher number is 3. It is again repeated 3 times, and that should have the rank 6, 7, and 8. So the average of 6, 7, 8 would be 7, 7, and 7. Now the next higher rank should be ninth, and then 10th. Again 4 is repeated twice, so ninth and 10th. The average of 9 and 10 gives us 9.5. Now 11th, 12th, and 13th rank should be assigned to this number 6, then 7, and then 9. And now we mark a tick across the ranks that are positive, because as per the formula we need to consider the ranks that are positive only. So 13 and 12 gives us 25, 25 and 7 gives us 32, 32 and 7 gives us 39, 39 and 8, 39 and 8 gives us 47, 47 and 10, 57, 57 and 11 gives us 68, 68 and 4 is 72, 72 and 4 is 76, and that's 78.5. So W calculated is 78.5, and it can be concluded, decision we can take as, since W calculated falls in the rejection region, therefore H naught is rejected. Similarly, we can draw the conclusion or write down the conclusion as the test results are statistically significant at the 0.05 significance level, and data provides sufficient evidence to conclude that We can draw this conclusion that the exercise reduces heart rate significantly. That's all.